In our previous notes, we learned about quadrilaterals, parallelograms, and rectangles. In these notes, we're going to prove that a four-sided figure is our first step is to plot our points. So A is at negative 5, 0. B is at negative 1, 3. C is at 2, negative 1. D is at negative 2, negative 4. I will now find or connect my dots. My second step is to find the slope of each line. The slope is important because if I can prove that each slope is perpendicular to the slope next to it, then I can prove that these four angles inside are right angles and therefore perpendicular. So I will create a slope triangle using a dotted line so I don't get confused. I'm going to count my rise, which is 3. My run is 4. Therefore, my slope is 3 over 4. I will go ahead and log that down here. A slope perpendicular to this would be negative 4 over 3. So just keep that in mind. I'm now going to find the slope of this line. The rise is 1, 2, 3, 4. The run is 1, 2, 3. And the line is going down from left to right. So that means it's going to have a negative slope. So I'm just going to make this number negative. It doesn't matter which number you make negative as long as you make one of them negative. The slope for this line is therefore negative 4 over 3, which is indeed perpendicular to 3/4. The fraction is flipped and the sign is changed. So I will go ahead and log that slope here. I'm now going to find the slopes of my last two lines. So DC, I will find this slope. The rise is 3, the run is 1, 2, 3, 4. So that means if this slope is 3/4, this slope is negative 4 over thirds, that's a right angle. We already said that this was a right angle because we know these slopes are perpendicular. So now we just need to figure out the slope of BC. And if BC is the same as negative 4/3, that means it'll be perpendicular to 3/4 and 3/4. So let's log this real quick. CD is positive 3/4. And lastly, BC has a rise of 1, 2, 3, 4. 1, 2, 3. The line is going down from left to right, so I'll make that negative. My rise is negative 4. My run is positive 3. So, therefore, negative 4/3 is perpendicular to 3/4, so I'll put a right angle here. And negative 4/3 is also perpendicular to positive 3/4. Proved that this is indeed a rectangle. So we've analyzed our slopes. If all the slopes are perpendicular, then the quadrilateral is a rectangle, so we know that. And how adjacent lines are perpendicular. So for my first one, I've given you a sentence starter to help us out. Line AB has a slope of 3/4. And line BC has a slope of negative 4/3. Therefore, the lines are perpendicular. In the second one, I will take BC and compare it to CD. So I'm just going to kind of go down the line. Line BC has a slope of negative 4/3, and line CD has a slope of 3/4. Therefore, the lines are, and I'm just going to write this over here on this side, perpendicular, and I'll just abbreviate it to perp. For 3, we're going to look at CD and compare it to DA. Line CD has a slope of 3/4, and line DA has a slope of -4/3. Therefore, the lines are perpendicular. For the last one, we're going to look at DA, which is here, and we're going to compare it back up to AB. And you'll notice on our diagram, DA and AB are in fact adjacent. So this makes sense. Line DA has a slope of -4/3, and line AB has a slope of 3/4. Therefore, the lines are perpendicular. This is a big question that you'll see on your final, so it definitely makes sense to understand how to do this. Make sure you're just following each step one at a time and labeling the sides, proving they're perpendicular, and following this format for your explanations.